Welcome to another advanced options video. Here I'm going to discuss the fourth characteristic of a viable option pricing model, and that is that put-call parity must hold. I talked about put-call parity in great detail in a prior video. Just a quick review. This equation right here represents put-call parity. The per share stock value plus the per share equivalent put price minus the per share call value when the put and the call are twins, same strike price, same expiration date, will be equal to the present value of the strike price. This is an equilibrium condition. Okay, put-call parity, that has to hold for our option pricing model to be viable. Now, so that's the condition. Now, as we've been doing in these recent videos, we now want to look at a violation of that condition and then see what we would do to arbitrage the condition if possible. And then we want to talk about how markets would go from the disequilibrium to an equilibrium. Okay? So in order to do that, we have this example here. Stock price is assumed to be 25. Strike price for the option is 25. The per share value of the call is 450. Per share value of the put 350. 4/10 of a year. Time remaining until expiration, and the risk-free rate in continuously compounded return form is 7%. Okay. So, given these numbers, these assumptions, let's see if put-call parity holds. Well, here we have a calculation for S plus P minus C, 25 plus 350 minus 450 is 24. And then here we have present value of strike price. It's X times E to the minus RT. There's the R value, there's the T value. And of course, there's 2431. So as the red lettering makes clear, S plus P minus C is less than the present value of strike price. Okay, S plus P minus C is less than the present value of strike price. S plus P minus C equals the present value of strike price is the equilibrium condition. The equilibrium condition is violated. So what will we do? Well, here it suggests we execute a conversion. The spreadsheet's built to describe the best action. And so we execute a conversion. Now we've described conversions before. We go long 100 shares, long a put and short a call, and making use of these prices here, the cash flows at date 0 are as shown. We're buying 100 shares at 25 each, so we spend $2,500. We're writing a call at a price of $450, so we receive $450. We're buying a put at a price of $350 for the contract, so we pay $350. The net cash flow at date 0 is minus $2,400, an outflow of $2,400. Now, at option expiration, 4/10 of a year later, we know that we will get a cash inflow as described in an earlier video of $2,500. You'll remember it's the strike price times 100. No matter what stock price is, this conversion will provide us with a cash inflow of X times 100, in this case 25 times 100 at the option expiration date. If you're fuzzy on that, go back and rewatch my put-call parity video. Okay, so our cash flows then right now at date 0 are an outflow of $2,400, and at option expiration 4/10 of a year later, an inflow of $2,500. Okay, so looking at it as an accountant might look at it, profit's $100, but we're more concerned with, did we earn an excess return? A return above and beyond the return that the risk-free rate would provide. And we can show what we would have earned if we'd invested at the risk-free rate. So I'll say equals absolute value of this. This is going to take care of the minus sign for us. And then we'll multiply that by e to the minus RT. So minus rate times time. And, oops, sorry. Here I'm just showing you what we would have earned. And so we don't need that minus sign, I'm sorry. Okay, so there. So if we would have invested $2,400 at 7% continuously compounded for 4/10 of a year, we would have ended up with $2,468 and about 15 cents 4/10 of a year later. But when we executed this conversion, we did better. We ended up with $2,500. So the difference between this $2,500 and this $2,468, which is $3,185, is our excess profit. Okay, so we did well, and that is what will happen in the markets if put-call parity doesn't hold. Well, let's see how markets would react to this. Well, as is the usual case, as is the typical case, the trades placed by the wannabe arbitrageurs are the forces that cause the arbitrage opportunity to eventually disappear and hence to restore equilibrium prices. So here we're buying the put, thereby driving up the price higher than 350. We're selling the call repeatedly by assumption and driving down its price. So as the call price gets lower and the put price gets higher, then you can see that we're adding a bigger number and subtracting a smaller number, and so this number is going to grow. Okay, and at some point we'll get an equilibrium when it's at 24.31. Okay, and that's how good markets work. Okay, well, let's look at one more example here quick. Let's just assume that the call value, instead of being $4.50, was $4 per share, or $400 for the contract. Okay, and so here's the equilibrium condition, S plus P minus C equals the present value strike price, and then we check and see if that's the case. Well, S plus P minus C equals 24.50, present value strike price hasn't changed, still 24.31. Now we see that S plus P minus C is greater than the present value strike price. And the suggested trade is a reverse conversion. A reverse conversion is just the opposite of a conversion. Instead of going long stock, long put, short call, we go short stock, short put, long call. And so let's look at the cash flows. Right now at date 0, we short 100 shares at 25 each, and we received 2,500. We short a put at 350, and we receive $350, and we buy a call and we pay $400. And the net cash flow is an inflow of $24.50 at date 0. Now at option expiration, we're not surprised that since we have a reverse conversion, that rather than having a cash inflow, we'll be left with a cash outflow of minus X times 100, in this case minus 2,500 at option expiration. So obviously we're getting 24.50. We're going to have to pay 2,500, at option expiration. And so if we look at it like an accountant, which is not a good way to look at it, in this case, we have a profit of minus 50, but we know that's not true, because what we're going to do with this 24.50 is we're going to go in and we're going to invest that. Okay, we're going to invest the 24.50 at a return of 7% CCR for 4/10 of a year. Okay, and so we're going to actually profit handsomely on this, because we're going to invest these proceeds again at a rate of 7% continuously compounded return for 4/10 of a year. And let's just see what our 24.50 will grow to. And okay, so here it'll be worth 25.1956 at option expiration. And then you look at the 1956 amount by which the absolute value of this exceeds this. And if you take that 1956 difference and you move it back in time to date 0, it's 1902. So I happen to have the excess profit here calculated as of date 0 rather than as of the option expiration date. No big deal. But so in this case, we have an excess profit stated in date 0 terms just by my choice of 1902. Again, we could have stated the excess profit as of the option expiration date, in which case it would be 1956. Okay, so there I've shown you what happens whenever S plus P minus C exceeds the present value of the strike price, and we execute a reverse conversion, and we see that we can profit from that. And okay, executing the arbitrage, earning the arbitrage profit, we do it as as often as we can. But again, how do good markets work? Well, here we're going long the call and short the put, so we're bidding up the price of the call to something higher than 4 and bidding down the price of the put to something less than 350, and eventually the S plus P minus C is going to sell at 24.31, so that we will again have put-call parity restored. Put-call parity is an equilibrium condition. And again, put-call parity is an equilibrium condition that has to be satisfied in a valid option pricing model. In fact, it's the 4th characteristic of a viable option pricing model. And so again, in summary, what we've seen in this video is that the 4th characteristic of a viable option pricing model is that put-call parity must hold for its predicted option prices. And that's all I have for now. Thanks for watching.